Good afternoon, I'm Dr. Steck. Welcome to the General Aviation Flight Lab at Wichita State University in Aerospace Engineering. We do research here in airplanes, flight dynamics, flight controls, artificial intelligence. We've done research for NASA, the FAA, airplane companies here in Wichita, as well as around the world. Today we're not going to show you a lot of the research, we're going to show you some of the cool things and tools that we use when we do our research. And Abbas and Robert are going to take it over and show you some of those.
Hello and welcome to the General Aviation Flight Lab, also known as GAFL. My name is Abbas and I'm a senior in Aerospace Engineering here at Wichita State.
My name is Robert Ross. I'm a junior studying Aerospace Engineering here at Wichita State.
Today we're going to be giving you a tour of our flight simulator and our driving simulator. Research is an important aspect of the GAFL, like Dr. Steck mentioned. We are involved in aeronautical aspects of artificial intelligence, machine learning, virtual reality, such as using the Google Glass, HoloLens, and so on. We also are involved in flight controls research with NASA, just like Dr. Steck mentioned, helping making aviation safer. A lot of times the GAFL will invite real-time pilots to try different scenarios on our flight simulators such that they can prevent incidents and gain more practice before they go out in real time to fly on actual airplanes. And like I said, to prevent incidents. One such incident was the Hudson River landing of 2009, where Captain Sully was in command of a U.S. Airways Airbus A320 headed from New York's LaGuardia Airport to Charlotte, North Carolina. The airplane, at an altitude of 2,800 feet, flew into a flock of Canadian geese, causing a dual engine failure and a total loss of power, where Captain Sully was able to land successfully in the Hudson. Robert here today is going to demonstrate the Hudson landing for us. As you can see, we are lined up on runway 04 of New York's LaGuardia Airport, ready for takeoff en route to Charlotte, North Carolina. And we are on our takeoff roll. Engines powered up. And we are rolling down the runway for a takeoff. That's a successful takeoff. Now the aircraft is climbing to get to its cruising altitude. Landing gear up. As you can see the New York skyline towards your left and some of the neighborhoods surrounding the LaGuardia Airport. The graphics on our system are very smooth thanks to a state-of-the-art system that we're running to power our flight simulator. Now Robert is at an altitude of around 800 feet. We are still not at a altitude where Captain Sully, back in January 2009, flew into a flock of Canadian geese, like I mentioned, causing a dual engine failure and a total loss of power. We are at 1,600 feet. We're still climbing, and you can see just the whole area around LaGuardia Airport. You've got some of the skyline towards our left, and we're at 2,400 feet, right around 2,800. Robert is going to simulate a dual engine failure. The aircraft will lose power to both its engines and will basically be a glider now. Now the engines are dead because of ingestion into our engines, and now Captain Sully, who Robert is simulating right now, contacts the air traffic control. Air traffic control tells Captain Sully that he can either return to LaGuardia or he can land at the nearby Teterboro Airport. Captain Sully quickly realizes that he will not be able to make it to any of those airports because the aircraft is losing altitude and does not have power. So the only option left is the nearby Hudson River. Now, what Robert is simulating is he is making an approach towards the Hudson River. As you can see, the New York skyline right over there, you can see the Empire State Building. very good graphics on our simulator, as you can tell, and we're gradually and slowly making our approach towards the Hudson River, the only option that Captain Sully has right now. Now note that he will try to make the slowest approach such that there is reduced impact once he lands onto the river, because we want to ensure that there's no loss of life, and we are trying to lose speed, but we're also trying to lose altitude. As you can see, we're making our way towards the Hudson River, which runs right between New York City. You can see Central Park right there, the Empire State Building, and the rest of the New York skyline is right over there. And we're approaching towards the Hudson River. We are at around 1,300 feet. Now, note that the landing gear has not been deployed on this Airbus A320 because Captain Sully wants to prevent any damage, because we do not want the gear to shear off once he lands onto the body of water. Now, the system, as you heard, gave him an altitude warning. There's a couple of sensors going off because that's not where an airplane is supposed to land. But that's the only option that Captain Sully had back then. And we're lining up for an approach onto the Hudson River. As you can see, the New York skyline is very close, but he is making his way towards the river. We are less than 600 feet in altitude. Flaps down. A couple of warnings go off once again to warn Captain Sully, but he is making his way gradually towards the Hudson River. Less than 200 feet, and we're about to hit the body of water.
100. 50. 40, 30, 20, 10.
There we go. On January 15, 2009, Captain Sully successfully landed this Airbus A320 of U.S. Airways onto the Hudson River. Captain Sully was named the hero of this landing, having saved the lives of everyone on board, including passengers and crew. Rescue personnel were able to save all the passengers within a few minutes. The aircraft that was involved in the incident is now on display in the museum in North Carolina. Now, like you saw, we used our flight simulator to practice an incident. Similarly, pilots can practice such situations to prevent them from happening in the near future. So as you can see, flight simulators are the future of aviation safety, and they're being extensively employed to help aviation. Now, after the Hudson River landing, Robert is going to be demonstrating a carrier landing and a carrier takeoff for us. Aircraft carriers are essential to the U.S. Navy. As you might have seen in the movies, they're basically big ships with a runway on board. However, since they're basically floating runways out in the ocean, the length of the runway is very short. Hence, what aircraft carriers use is a system of catapult launches powered by steam or electromagnets, which propel the aircraft to speeds of up to 130 miles per hour within 2 seconds, making sure that the aircraft takes off at the end of the deck and is off for its mission. Aircraft carriers are home to a wide variety of aircraft, and just like you saw, as soon as Robert released the brakes, the catapult launch propelled him towards takeoff. Now what Robert is going to demonstrate is he's going to loop back and is going to attempt to land back on the aircraft carrier using a visual approach.
And right now, the United States Navy and Air Force are both looking into using flight simulators to train new pilots in order to save both time and money for new pilot training.
So like I mentioned, we're going to loop back and get a visual idea of where the aircraft carrier is, and then we're going to make an approach back onto the flight deck. We're in the Long Island region, if I'm not mistaken right now. As you can see, we have the skyline towards our left. Once again, as you can tell, our system is very smooth. The graphics on this flight simulator are state-of-the-art because of the systems we have installed here at the General Aviation Flight Lab.
Currently flying an F-4 Phantom, which is an aircraft that was used by both the United States Navy, the Air Force, and the Marine Corps during the Vietnam War. So this is a bit of an antique, but still a pretty cool fighter jet.
So somebody asked in the comments, how does practicing a flight simulator help an engineer?
Well, if you're studying aerospace engineering specifically, it gives you a good idea of how the flight controls work on an airplane. I'm actually in a class right now called Fundamentals of Flight, and we're about to do a project where we have to design and build a glider using X-plane, and we're going to have to design that glider so that it'll fly as long as possible without any engine power, and we're going to be flying in an X-plane. So for that specific class, that's why it's helpful for me to know how to use X-plane and also knowing how to fly.
And to add on to Robert's answer, flight simulation can really help you to apply what you learn in class to a real-time situation. So figuring out how a specific control in an aircraft would look like in real time when you're not able to do it on an actual airplane, but you can do it in a flight simulator, which reduces not only the cost, but it's also a safer way to do so.
Call the ball.
Now, carrier landings are kind of tricky. Since the runway is short, like we had mentioned earlier, the aircraft has to stop in a designated length of runway.
You're overpowered.
Aircraft carriers use a system of cables that are on the deck,
You're overpowered.
and the aircraft making its approach has a hook on board.
You're overpowered.
Pilots are going to attempt to latch onto that
You're overpowered.
cable using the hook that they have on the fuselage to stop the aircraft before it reaches the end of the runway. There are 3 to 4 cables on the deck which the hook attaches onto to stop the aircraft at the end of the runway.
You're low.
Now, as you can see, the aircraft guidance is helping Robert towards the
You're low.
runway on the flight deck of this aircraft carrier.
You're low.
Another challenge is that the runway on that flight deck of the aircraft carrier is at an angle to where the ship is going, so you're trying to land on a moving target or a moving runway.
You're overpowered.
That's the runway right there. As you can see, the pilot will attempt to latch onto the cables using the hook that they have on the aircraft. We're almost there. Now, for instance, in situations like this, pilots immediately put the aircraft into full power for safety reasons, such that they can take off again and make another approach back onto the aircraft carrier. It's very routine to do so for safety purposes. That once they hit the deck, and if the aircraft is unable to latch onto one of those cables, the aircraft throttles up and makes another attempt such that it does not fall towards the end of the runway.
So yeah, when naval aviators are landing on an aircraft, the first thing they do as soon as the wheels hit the ground is they actually go back to full power, which seems counterintuitive since you're trying to stop in a short distance, but like Bob said, that's to make sure you have a bolter, which is what they call it when you miss the cables like I just did, so you don't stall as soon as you go off the end of the runway and hit the water.
Banking again, and we're going to make another approach to land onto the aircraft carrier. The aircraft carrier right there. Now what Robert is trying to do is he's not only trying to lose altitude, but he's also reducing his speed.
Call the ball. ILS 108.10. Heading 082. Your low.
The system helps guide the pilot towards the aircraft carrier, as you can hear.
It's kind of hard to see, but that phrase they said at the beginning, when they said call the ball, it's a phrase they use in naval aviation, which tells the pilot to start looking for a set of lights on the left side of the runway of an aircraft carrier. And that tells them how high or low they are and if they're on their speed or not.
Your low. Your low.
So another question that we have in the comments is, do all students majoring in aerospace engineering take flight controls
You're overpowered.
and or use the simulator?
You're overpowered.
So,
Overpowered.
Fundamentals of Atmospheric Flight is a class required by the Aerospace Engineering catalog. However, to get access to the flight simulator, you can apply to be part of our research group, and you can gain access to work on one of these flight
You're
simulators.
overpowered.
Similarly, Wichita State has multiple flight simulators installed in the John Bardow Center. Although there are not multiple screens like this one, because of the nature of this aircraft simulator, it is still very similar to what we have over here. So yes, to answer your question, students do have access to flight simulators here on campus. Either this one if you're part of our research group, or as a student, you can access the flight simulators at the John Bardow Center.
And I'm actually working here through what's called the NASA and Kansas Jumpstart program. It's a grant-funded program that's paid for by NASA for students like me. Starting out freshman year, you can apply for it, and it basically just gives you an opportunity to work in a lab like this. It doesn't necessarily have to be this lab. There's several other researchers that you can work for, but I was a student pilot at the time and knew I was interested in aviation and heard about the flight lab and decided it would be perfect. So here I am, and I actually get paid to fly flight simulators as part of my job, so it's pretty fantastic. All right, so now what we're going to do is we're actually going to demonstrate the driving simulator portion of this. So we're going to switch this from flying airplanes to driving race cars, and we're going to demonstrate how that switch works.
So our lab has the capability of transforming this entire setup to a driving simulator within a few minutes, which we will demonstrate to you here.
And we should introduce Melvin. Melvin built the flight simulator and the racing simulator. So kudos to him for doing all this. Yeah.
As you can see, we have latches over here, enabling us to transform our flight simulator to a driving simulator within a few minutes. We'll take this one over here.
Actually, go wherever you are.
Okay.
So this is the new addition to our simulator. It's a racing chair. Basically, the chair in it is actually a chair like you would find in a race car. And as you can see, it's got wheels and a pedal and everything you need to drive a car.
So in a lab that mainly focuses on planes and research relating to planes, what's the purpose of having a racing simulator as well?
Because it's fun.
Because it's fun.
The WSU does have a small racing car team. I don't know what the name of it is, but there's a team that builds and races small Indy type cars.
SAE, I think. Yeah.
Formula SAE, yeah, right. Thanks.
Yeah. Great.
Yep.
So now Boss is going to demonstrate our new racing simulator. We've got a couple of different racing software simulators on here. This is one called iRacing, but we also have a couple of different Forza simulators on here as well. The wheel is a force feedback wheel, so it actually has a motor in it that opposes the driver turning the wheel. So you've got some kind of force acting on the wheel. It's not just doesn't spin freely. So if you've ever driven a car, it actually feels very realistic. It's got paddle shifters on it, so you can do automatic or manual essentially, and 3 pedals for the gas, brake, and the clutch. Any other questions?
Nothing so far. So you mentioned earlier that you were a student pilot, Robert. What got you interested in becoming a pilot?
Honestly, I'm not really sure. I've kind of always been interested in it. Flying is something I've always really wanted to do. I started my flight training when I was in high school and finished up my license the summer between my freshman and sophomore year here at Wichita State. So it's just something I've always wanted to do. So.
Very cool.
You got the cord, you know to put in and give out that card.
How often do you guys use the racing simulator versus the X-plane simulator?
The driving simulator is pretty new, so we don't use it as much. Personally, that's one of the perks of working here is unless the simulator is being used for research, I can come in and fly it pretty much just for fun or just to practice for flight training anytime I want. So I use X-plane a lot. I don't think we've used the driving simulator for any research projects yet, but it's not to say it might happen sometime soon. So for the moment, right now, we use the simulator mostly for flying. But, all right, so there you go. That was a full lap at the course, and I believe that's somewhere in California. But
Yeah, that's the Laguna Seca. But yeah, thank you
Yep.
for joining us today at the General Aviation Flight Lab. We hope you enjoyed.
and if you'd like to find some more information about the flight lab, you can go to wichita.edu/GAFL. So yeah,
Have a great day.
and we can answer some more questions if there are any.
Yeah, so if you have any questions, leave them in the comments. I don't see any right now. Are there any questions that you guys commonly get that you would like to address relating to your major or the lab?
Ones you guys asked were pretty much along the lines of
Yeah.
what we get frequently asked. So thank you, and we appreciate you for joining us today. Have a great rest of your day.
All right, thanks.